Thank you, Kitaki, for your excellent talk on leveraging Flink for observability and AI ops. Your expertise provides us a fresh perspective on structured event systems. So for our final session of this day, we are excited to welcome Lanley Long, Senior Operation and Maintenance Development Engineer and Grab Holdings INC. Yeah, please.
Hello everyone, thanks for coming. Today I'll be discussing this topic, enhancing Flink deployment with downtime-free shadow testing. Yeah, currently I'm working as a DevOps Engineer in Grab platform team, which is managing the stream processing platform. And we actually manage several hundred Flink application and also the infrastructure. And this will be the agenda that we'll be talking today. Actually, it will be divided into 3 parts. We'll be talking about the challenges of the deployment and testing, and deployment flow with shadow testing, and also some of the simple use case when we implement this shadow testing feature. Before I jump into how the implementation of the shadow testing, I want to discuss about the challenges that we face when we implement the shadow deployment to our Flink application. For us, it's actually very difficult to deploy critical real-time and stateful application in production, because it will impact stability such as the business operation, like booking service and some of our delivery service. And also it may impact some of the Flink application pipeline where it will ingest some of the financial data to data warehouse. So you also, there's a potential of writing duplicate or corrupted data to the production Flink application when they deploy some faulty deployments. And then previously we also have this kind of canary deployment with some auto rollback feature. But then this one, which actually will cause some short downtime to our Flink applications. So it's still not ideal to continue using this kind of solution. And then it's also very difficult to simulate production data in staging, because staging actually traffic is actually much lower scale as compared to the production data. So based on this challenge, I will deep dive some of the challenges. For example, let's say in previous canary deployment that we use for our Flink application, there are some, when platform user deploy their Flink application to the production pipeline, actually we actually integrated a Kubernetes cron job to monitor the Flink application deployment. So in this stage, actually the cron job actually will monitor for about 10 minutes. But then in this 10 minutes, actually it will monitor the Flink application job manager's status. And during this 10 minutes, actually the Flink application may run in the transient state. So it could be not performing as expected. So if it's failed, then actually it will be auto rollback. But then during this 10-minute downtime, it's actually quite critical for the real-time and stateful applications. And then previously I talked about it's very difficult to simulate large production data in staging. So this is a timeline that we try to solve this kind of challenge when we try to implement this shadow testing to our Flink application. So normally staging data is actually mostly our testing data. It's not really actual mimic of production data. When platform user deploy the application in staging, it may work, but then in production it may break, because sometimes staging data you cannot cover all the edge cases in production. So what we did actually to improving this issue, actually we try to mimic mocking large dummy data into the staging to simulate production scale kind of data. But then this dummy data, large dummy data, actually not that useful for some of the Flink application. For example, some of the application may be for machine learning purpose. So those dummy data are actually not that useful for them. And then After that, we actually try to mirror production data to staging. But then, in order to do this, we actually need to set up a very complicated network setup between the production and staging. But then, in doing so, actually, it will also pose some security concerns because we are exposing production data in staging. So it's not really the ideal. So we also mock the production data in the staging. Yeah. So there are multiple challenges before we come to the shadow testing. So I will try to discuss how we implement the shadow testing in our Flink application and its architecture. Before I talk about the architecture, I want to briefly explain what is actually shadow testing, because not many people actually understand what is the concept of shadow testing, because there are many type of testing framework that we can use. So a shadow testing is actually a testing technique that whereby we can mimic production data, and then in parallel we can actually deploy application in parallel with the existing live application with the newer version. So, and then it will involve some replicating production data, production traffic data, and then to the new version and compare with its behavior with the current one. So it's actually it's able to simulate the production traffic and also some of the large scale of data. And then usually these shadow resources are usually short-lived. So actually, this is actually just a very brief overview of our current deployment flow. So the shadow staging stages actually we implement it actually to the existing deployment flow. So yeah, it's actually just a flow chart. Yeah. So when platform user deploy, because actually they are currently our deployment flow actually have two modes. You can either select normal mode or shadow mode. So if platform user choose to deploy the application using the shadow mode, it actually will auto set up the shadow pipelines in different Kubernetes namespace. So it will actually isolate the shadow application with the existing live application. And then the duration of shadow testing on this shadow pipeline actually will be default of 1 hour. There will be one dedicated cron job actually will be auto set up together with this shadow pipeline. So during this 1 hour, actually, it will perform some shadow testing against the job manager status API. So it either will return pass or fail. So if it fail, actually, yeah, it actually will be stopped there. So it will be pending user to debug the shadow pipeline. If yes, then it actually will send the notification to the user to whether they want to approve or reject the deployment of the new version of the application to the production. I will explain a bit more detail in the actual architecture. Yeah, so in Flink application itself, actually, user or platform user or as a platform engineer actually, by introducing this shadow environment variable, right, actually we can override, based on this shadow environment variable, actually we can override the config, the Flink application config, to perform shadow source or sync operation, or no ops with metrics. Or else, it's usually just do a normal source and sync operation, which is a live application. So yeah, this is actually some of the critical component of deployment flow. So normally, Flink application, it can perform either as a source or sync connector. So if the shadow environment is false, actually you will just do a normal live application. It will have its own job ID, and then you will sync to its own original sync, and also for some auxiliary, you will sync to a metrics and logging. But then they will have their own, they will be deployed in their own existing Kubernetes namespace, and then their application checkpoint and save point will be in the existing path also. But for when platform user actually deploy them using the shadow mode, it's actually the shadow application will have its own job ID. And then this job ID is actually MD5 hash of application name. And then with the shadow application, it's usually just with the shadow prefix. So this job ID is usually unique for live application and also shadow application. And then for shadow application, actually it will be deployed in a different Kubernetes namespace. So they will be in isolation. And they will then, because in the previous slides, when you have this shadow environment variable, right, you can actually override the configuration of the thing. Yeah. So for observability-wise, right, actually, right, let's say for metrics, you are using state D. You actually can override the state D configuration to inject the shadow prefix. So in terms of observability, actually, platform user can just toggle based on the tag and filter, because shadow pipeline have their own dedicated prefix. Same goes to the checkpoint and save point. They will be synced to they will be saved to the different path. So you will not corrupt with the existing live application states. So after I talk about the architecture, how we implement the shadow testing, I want to discuss briefly about the sample use case that commonly we have in Grab. Yeah, so as a platform team, we'll provide the common module, which is actually just a Flink application code that will be bundled as a library for platform user to use. So let's say for our Kafka source, actually, right, for shadow pipeline, actually, it will be auto set up the dedicated consumer group. For example, let's say in this case, the shadow consumer group will be injected with the shadow suffix. So it will prevent committing offset to the Kafka broker. Kafka offset in this scenario is actually just a unique identifier or index of the topic message in Kafka partition. So it will actually determine the consumer whether last successfully processed message in the Kafka topic. So it's crucial for not corrupting the existing live consumer group. And for Kafka sync, actually, we can, for shadow pipeline, actually, it will just auto create the topic in the shadow Kafka broker, and with 8-hour retention, for example. And then this will prevent actually writing to the same existing live topic, prevent duplication or corrupted data. And for S3 string, yeah, it's actually will just to auto sync to the dedicated shadow bucket. For example, let's say with a shadow prefix and with 7-day retention. Because for shadow, you don't really need to keep for a long period. And then you can, with this dedicated shadow bucket, actually you can perform a different independent analysis on those shadow data to compare it, whether they are really matched with the existing live production data. And for CDC source also, we actually can override the server ID range for the CDC source connector. For example, let's say existing server ID range that we use are actually from 1,000 to 1,999. Actually, we can just increment the shadow server ID range by 1,000. Yeah. So by doing this, actually, we can make sure that the shadow pipeline have their own unique range of DB clients, so you can read the bin log and process successfully from the source DB. Okay, so what's next? Actually, right, since we already deployed the shadow testing feature to production, there are still some challenges that to deploy application for currently not supported custom connector. Because what I mentioned here are 4 commonly used connector in Grab. So in the meantime, we can support more source and sinks connector for wider adoption. And some less used custom connector will be using no ops with metrics. Yeah. Yeah, thanks for listening. Yeah, any question, yeah, you can direct it to me. Yeah.
Do you have any questions? Okay, then thank you, Li Hong. So thanks. So with the conclusion of Li Long's presentation this afternoon, real-time analytics track 2 has officially come to close. So before we part ways, I'd like to take a moment to thank all our incredible speakers for their thought-provoking sessions and contributions. A huge thanks to all of you in the audience for your participation and for taking the time to join us today. And as we conclude Flink Forward Asia 2025, okay, I'm thrilled to share some exciting news. Flink Forward Barcelona 2025 is just around the corner. The global gathering will take place from October 13 to 16, and will showcase the latest innovations, success stories, and technical deep dives from the world of real-time data streaming. So, as always, technology has no boundaries, and Flink Forward is a platform to explore new frontiers together. Let's looking forward to continuing this journey and shape the future of real-time processing. So since our track concludes slightly earlier than others, I encourage you to take this opportunity to explore other ongoing sessions here at Flink Forward before you go. And also at the end of after all the sessions close, so we will have a group photo downstairs on the third floor. So please don't leave. Let's take a group photo all together. Okay, so this concludes this session today. And thank you for joining this session.